Section 8.4, angles of elevation and depression. We're going to use these to solve problems. Here's what the difference is. Angles of elevation are formed by a horizontal line and the line of sight above the horizontal line. So angles of elevation, if I'm looking directly to the back of the room and I put my arm out, it's kind of like this is the horizontal line that I'm looking at. If I look up to something in the sky, from your line of vision to that point in the sky would be going up, right? That would be an angle of elevation. If I'm looking to the back of the room and I look down at the floor, from my line of vision to that point on the floor, I'm going to be changing my line from straight to down. That would be an angle of depression. That's really the only difference. We're going to be solving the questions by using trig, and you will definitely see kind of a pattern when we do that. Okay, so here's a picture. I'm going to make it a little bit bigger. Okay, that's a little better. So when you're looking at it, here's the person. The horizontal line is right here. When she changes from looking straight ahead to looking up at the plane, this angle right here, this 38, is an angle of elevation. Doesn't matter that that's at the bottom. It's what was eye level and where are you looking now. So if you change from going straight to looking up, that would be an angle of elevation. From this perspective right here, this person was looking straight this way, and they chose to look down at the person. So they were looking straight, now they're looking down. That one would be the angle of depression. Okay, so it's kind of like, where are your eyes moving to? Okay, so now I'm bring it back down. So what's a description of the angle as it relates to the situation shown? So when we are looking at this one, looking at the picture, the angles of elevation. Okay, so when you are looking at this person right here, which one is elevation, 2 or 3? 2, because they were looking straight and then they looked up at the bird. So an angle of elevation would be angle 2. What's 3 then? Depression. So they were looking straight and then they chose to look down. So I'm going to put depression in angle 3. What about angle 1? What would that one be?
Depression from the bird's perspective.
Yep, from the bird. The bird was looking straight and then chose to look down at the balloon. So an angle of depression would be angle 1. And then what would angle 4 be?
Angle of elevation.
Elevation, and that's kind of from the mountain. I mean, not that the mountain looks, but they were looking this way and looked up if there was something down there. So 4 would also be an angle of elevation. So when you're doing that, the most important part is you have to kind of look at the angle. From the bottom to the top, what is it doing? This one is getting bigger, okay? From here, this one is getting smaller. So you're looking from straight on, and what's it doing from the angle? You don't look at it from like here, like this one. You don't look at angle 4 like that. You're looking at angle 4 from here, like where the angle starts, okay, on the inside. So part of it, you're going to have to identify what they are, angle of depression or angle of elevation. The other part is you're going to have to figure out what they are missing. You are standing 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So now I'm going to have to look at my numbers again. Okay, so first of all, when a picture is given, excuse me, it's easier. When it isn't, you have to draw one. So how do you put all of that into a drawing of some sort? Okay, so here's the words again. It says your angle of elevation. So it was straight, and now you are looking up. Okay, so right here, that's your angle. And the angle it said was 56.5. It always forms some sort of a triangle, and that triangle is always a right triangle. Okay, then the rest of it said your eye level is 5.5 feet above the ground. Okay, so here you have a person standing right here, this person is 5.5 feet tall. Okay, so it's not inside the triangle, it's person, okay, to the eye level. And it also says you are standing 53 feet from a turbine. So let's say the turbine is kind of up over here. This length right here, I should do that in a different color just a second. This distance right here, 53 feet. Okay, so when we are looking at working on this one, we know that our angle is here. Which of the sides would be opposite? The one straight across or the one to the left of it? Like which one of these? Is this one opposite or is this one opposite? First or second? First one. So over here is opposite. I'm going to put an O there with a line just because I know it's a letter and not a number. What's this one? H, because it's opposite the square. What is the 53 then? Okay, so still thinking about trig, we want to find the height, right? How tall is it? So we want the O. Okay, we are going to use tangent, but what you need to do is, okay, if I want O, that means cosine is not an option that we're going to actually use because you wouldn't be able to do it. We do want the O, and the other number that we were given is the A. So tangent is the correct one. Tangent 56.5 equals opposite over 53. So O over A. Do I multiply these or divide? Multiply. So 53 tangent 56.5. Okay, 53 tangent. Jesse, what'd you get? 80.1. Okay, 80.1 is correct. So 80.1 feet. Again, you have to have the setup in there. If they don't have a picture, make a little sketch. Okay, now, have we answered the question? That's what we have to think about. How tall is the turbine from the ground to its hub? So you remember that little person that was standing here? This measurement really is from eye level, right? So what do we have to add on to this 80 number? The person's height, right? Or the eye level thing. So we weren't actually done yet. Yikes, this is going all over the place today. I'm going to unsquare this one because we do have to add that person's height on there. So the height is 85.6 feet. Your triangles will always be at eye level, so sometimes you might have to subtract the height off of there if it's included. Sometimes you might have to add it back in at the end. So always read the question just to be sure. Got it. Number 2, you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground. You are 1,000 feet from the base of the cliff. Does this sound kind of like the last one that we just did? They all kind of sound similar. Sometimes you're looking up, sometimes you're looking down. So this one is also an elevation question. So we're going to draw an angle like this. The angle was 32. This to the ground is 6 feet. You can draw a little person if you want to. We are 1,000 feet from the base of the cliff. So person is here, and cliff is here. Okay, what is the approximate height of the rock climber from the ground? So we are looking at the height of this one is what we're looking for. I'm going to call it O still because height kind of makes it look like it's the H. So that's kind of what we're looking at. Here's my angle. This is my opposite side. This is my adjacent side. What do we use again? tangent. You're going to be using tangent a lot today, so if you think you're doing them wrong, you are not. It's kind of a tangent kind of thing most of the time. So tangent 32, opposite over 1,000. Again, we multiply. 1,000 tangent 32. And then do we add on or take off the 6? Add it on because the person started at the base of the cliff, not 6 feet up. So we're adding 6. And feet. So I need basically those things. Okay, problem 3. To approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent. So they are going from straight, right? And they're going to be landing eventually. So is that elevation or depression? Depression, does it matter if you know that? For the picture it does, but to do the question it probably doesn't necessarily matter all that much. So we are looking at something that they already have a picture for. So the plane is coming in and they start descending at a 3-degree angle to the airport. Now notice the picture that they have on the left and the picture they have on the right, which is kind of turned into the triangle. Let me make that a little bigger for you. Notice where the 3 degrees is. You can't do the 3 right here because they're going from straight and they go down. So the 3 degrees is actually outside your triangle. In order to make it work so that it is inside the triangle, these are parallel. And we know that with parallel lines, alternate interior angles are the same. That's why they have the 3 down there. Okay, so the depression ones are actually a little harder because if you do it with the 3 inside right here, you won't get it right. Okay, so it is kind of a little bit tricky there. Just remember with depression, you have to use alternate interior angles. So I'm going to put a note here, alternate interior angles. And then we'll mark them. So looking at this, and I didn't read the rest, let me tell you what it is. The height is 2,714 feet above sea level. The airport is 1,007 feet above sea level. And they have, to the nearest 1/10 of a mile, how far from the runway is the airplane at the start of the approach? So starting from a height of 2,714, the airport is 1,007. What do they do with these numbers to get 1,707? They subtract them. They're doing that's how they get that one. Otherwise, there's too many numbers to pick from. So sometimes you have to put them together. And they're looking at height above sea level. So you do have to put them together. Then we label. So I'm going to make it bigger again. So if this is my angle, this would be my opposite side. And what they are looking for is how far away. So I'm assuming they're looking for this one. What is that again? O and A are tangent again. So tangent of 3 equals 1707 over A. Divide on this one. So if you would have put the 3 at the top, you would have had O over 1707 and you would have multiplied, which would not have given you the right thing. So it is not the same thing. So we're going to take 1707 divided by the tangent of 3. I got a bigger number than you. I got 32,571. Did you divide?
Yeah.
Okay, do it one more time. So 1707 divided by tangent of 3.
Oh, why?
Yep.
I divided the one else.
And they want to know to the nearest 1/10 of a mile. Right now we're in feet, correct? How do we convert that to miles? Yep, so 5280 we're going to divide by, and that will turn it into miles. So sometimes you have to do a little conversion. So it is about 6.2 miles. Still tangent. Have we used anything else except for tangent today? No, but you have to have the things in the right place. Depression, I feel like, is definitely a little harder because of that little angle switch that you have to do. But let's do, I think there's one more maybe. Yeah. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3. This time we don't have a picture. So we have a plane like this and an angle of depression like that. It kind of forms like a backward Z. This right here is the 26 degrees. I'm going to show you one other way that you could do this one too. The right angle is there. The airplane's altitude is 3. What is the horizontal distance from the raft? So the raft is down here. Airplane up here. Okay, so they want to know that part right there. Now, if we have something like this, wouldn't this form a right angle here too? So you remember how we had to divide on the last one? What if we get those wrong every single time we do them? If we wanted to, we could take and find this angle right here, which would be 90 minus 26. And if you do that, you can multiply every time you do this. Okay, so I'm going to show you just a slightly different way. We'll do it both ways to show you the answer is the same. So 90 minus 26 would be 64. So instead of using the 26 like it would be down here, we're going to use 64 just to show you that it does work the same. If we use 64, this one over here would be opposite. This one would be adjacent. If we did it the other way and used the 26, the 3 would be opposite, the x would be adjacent. Okay, so looking at this one, it is tangent 64 equals x over 3. Notice how that one gives you a multiplication question. If you do the other one, if I put 26 down here, that would be opposite, this would be adjacent, and we would have tangent 26 equals 3 over x. That's a division question. So let's see if we get the same answer for both.
That's 6.2.
So 3 tangent 64 is 6.2. And 3 divided by tangent 26 is also 6.2. So if you are looking at this one, and it must be kilometers, and you look at someone else's and go, how did you do this one? And you say, oh, I was thinking I would do it this way, but you did it that way. As long as you get the same answer, you are fine. I would look at both. I usually do the subtracting because the multiplying is easier, but it doesn't truly matter. So here's one way. Here's the other way. Okay, and of course you don't have to do both. You would just do one. So a lot of tangent questions today. Just because we only use tangent doesn't mean there's not one that they word differently that you could use a different trig function. You still have to pay attention, but most of these are tangent. And I think there's one on your assignment today that isn't, but let's look at the worksheet that we have.